Tailings dam failure. Thermal plus LiDAR detection. Tailings dams don't fail suddenly. They fail in silence first. Long before collapse, thermal signatures and LiDAR scans reveal early deformation, seepage and structural fatigue that the human eye can't detect from ground level. Thermal sensors detect heat anomalies that indicate seepage through the dam wall. As water or slurry escapes internally, it cools or warms those sections at abnormal rates. What appears visually flat and stable can show strong temperature contrast in thermal view, signaling exponential risk. Thermal drones allow continuous, non-contact monitoring. Flights during early morning and late evening produce the highest contrast, because the dam surface cools at different speeds depending on permeability, trapped moisture and internal pressure. A seepage route glows distinct from intact material. LiDAR strengthens detection by measuring physical deformation. Millimeter-level displacement across the wall can be tracked week to week, layer to layer. What looks visually unchanged is often bowing, bulging or settling under hydraulic stress. LiDAR doesn't just show where the wall is today. It shows how it is moving over time. Microsettlement, slope creep and foundation stress present as geometric shifts that, if ignored, become irreversible failure conditions. When thermal and LiDAR are combined, risk becomes quantifiable. Thermal indicates internal moisture pathways. LiDAR defines structural movement. Together they create a predictive warning system instead of a post-failure investigation. Flight planning for tailings integrity requires routine overlap patterns, identical altitude, repeatable scan angles and consistent daylight conditions. This creates time series data where changes stand out instantly. No guesswork, no manual subjective reporting. Display timeline view, month 1, month 3, month 7, showing deformation trendline increasing. Once data is collected, analytics platforms classify risk zones. High seepage plus high movement forms the red priority band. Medium seepage with low deformation forms an amber watch list. Dry but shifting walls become separate structural alerts. This approach matters because tailings failures are not just environmental risk. They are financial collapse, ESG violation and irreversible community damage. A breach can wipe out operations, licenses, and mine reputation instantly. Drone-based thermal and LiDAR reduce false confidence. Instead of assuming wall stability from visual survey alone, digital scans reveal internal change at its earliest stage. No scaffolding, no manual wall climbing, no survey crews placed at risk. This workflow is now being adopted across iron ore, copper, lithium, gold and rare earth operations. Major operators integrate drone thermography into weekly pit to tailings integrity cycles and use LiDAR deformation models to justify reinforcement, drainage improvement and buttress installation. Tailings dams don't fail without warning. They speak in heat signatures and geometry shifts. Thermal analysis detects seepage. LiDAR detects movement. Together they convert invisible risk into actionable stability decisions. Safeguard the wall. Protect the mine. Protect the community. Like and download the checklist from the description below. Subscribe for more mining automation.